number 8 from Design and Analysis of Algorithms Laboratory is to find a minimum cost spanning tree for a given undirected graph by using Kruskal's algorithm. So in this Java program, we have defined a class called Kruskal, and we have defined a single dimensional array called as parent with a capacity to hold 10 integer numbers. So we shall be using this array to store parent vertices of a particular vertex. And then we have a member function called as find, which returns an integer number and also takes an input parameter called as m, which is also of the type integer, wherein m represents the vertex whose parent vertex is to be found out. So then in the find function, we initially assign the vertex m to p. M stands for a vertex whose parent is to be found out, and then we call in the while loop, we make a call to parent of p such that we try to check to see if the vertex whose parent we are supposed to find out is not set to 0. So if it is set to 0, if it is not set to 0, then we make p as its parent and then return. So in the next method, that is union, we are going to make use of the ranking based technique to arrange two vertice parents in appropriate fashion. So here I represents one vertex and j represents the other vertex. So I and j are passed as input parameters to this function union. And then we check if I is lesser than j. So if that is the case, I comes before j, then we say that the parent of I is equal to j. Otherwise, parent of j is equal to I. So then we also have a function called as solve. So in this function solve, we are passing two parameters. One is a two-dimensional array called as A, which is nothing but the adjacency matrix, and the other one is N. N stands for number of vertices. We have declared variables u, v, k, sum and min, where u stands for the first vertex, v stands for the second vertex, and k is just a counter variable to keep track of number of iterations, and sum is to hold the sum of the minimum cost spanning tree. So initially it is set to 0, and min is nothing but it shall be holding the minimum value of the edge. So then using a while loop, we shall iterate through all the edges. So therefore, if in a given graph having n number of vertices, then we will have n minus 1 number of edges in it. So therefore, while k is less than n minus 1, what we do is initially we assign min a value equal to 99. 99 is nothing but a replacement for infinity. So then we shall start iterating through the entire weighted matrix here using two for loops, where I starts from 1 to n and similarly j also starts from 1 to n. And then in this statement, if a of ij less than min and if I is not equal to j, we are trying to select an edge which is having a minimum cost when compared to variable min, and we are also trying to skip the iteration if it is a self loop, right? So therefore in this case, if the edge going from I to j is having a cost that is less than minimum, and if vertex I is distinct from vertex j, Then we change the value of min by the edge that is running from I to j. So therefore we get its cost from a of I comma j. And then we set u, the source vertex, first vertex, as with the vertex of value I, and we set the second vertex v with the vertex value of j. So this if statement is going to be repeated for all the vertices in the graph. So once we have already listed out what are the values of I in u, what is the value of j in v. So after it we shall make a call to function find by passing parameters u and v. So after finding the edge with the minimum cost, that is u and v, we now try to find the parents of these vertices. So the parents of these vertices will again be assigned into variables I and j, right? And then we try to compare to see if both I and j are two distinct vertices. So therefore we rank them by union. And we try to show the current edge on the screen. Therefore we add the cost to it. So we try to print the edge, and then for the minimum cost spanning tree to be constructed, what we are supposed to do is we add the cost of the edge coming from u to v to the variable sum. So each time you find a minimum cost edge, the cost of that particular edge shall be added upon with the variable sum, and k is iterated by 1 each time. And if there is no edge between two vertices u and v, then auv is equal to avu, which both is said to be infinity. So we set the current minimum edge cost as infinity, so that the next time we are not going to select the same edge. So we consider as if the edge is a visited edge is not present in the graph. We make an assignment auv equal to avu is equal to 99 because it's a bidirectional graph. So once all the minimum cost edges are found, their sum is obtained, the next statement is to print this cost of the minimum spanning tree. So the sum is available to us in the variable sum. So then in the main method, we are declaring an object called as scan of the type class scanner, and then we have declared an object called as Kruskal, which is of the type class Kruskal. So n is an integer variable, stands for number of vertices, and A is again a two-dimensional array with a capacity to hold 100 numbers in it. It is used to represent the adjacency matrix of the given graph. And then we ask the user to enter the total number of vertices in the graph. So we read it using nextInt method of the scan object and assign it to n. So similarly, we then read the adjacency matrix wherein I ranges from 1 to n and j also ranges from 1 to n. So a of ij, we get its value again from the user by making use of nextInt method on the object scan. So once we read the content of the matrix, we now make a call to function Kruskal, passing the adjacency matrix and number of vertices as its input parameters. So once you make a call to function solve is internally going to make a call to find and union. So it is going to find a minimal cost edge, and it is going union is going to add these edges to the minimal spanning tree. So now let us see how exactly this program works. So now it is asking us to enter the number of vertices. So let me say we have a graph with 5 vertices in it, and there is no edge from A to A, so it is infinity. We'll put it as 99. A to B, there is an edge with a cost 3. A to C, no edge. A to D, no edge. A to E, no edge. And then B to A, there is an edge with a cost 3. And B to B, no edge. B to C is 1. B to D, there is no edge. And B to E, there is no edge. Similarly, D to A, there is no edge. And D to B is 1. D to, it is C to B, there is our edge with cost 1. C to C, there is no edge. And then C to D is equal to 6. C to E, let us consider the cost of the edge to be 4. And then D to A, no edge. D to B, there is no edge. D to C, the cost is 6. D to D, no edge. And D to E, let us say there is no edge. For more clarity, you can draw this graph in the paper according to the values of this adjacency matrix. So you can observe here the very first what Kruskal's algorithm does is it is going to select the edges which have minimum weights initially, and then after it finds every edge it is trying to join it, or it is going to do a union of all these edges in the minimum cost spanning tree. So as you notice, there is an edge going from vertex 2 to vertex 3. Vertex 2 to vertex 3 whose cost is 1. So it is the very first vertex that is detected. And then the next least cost edge available to us is an edge going from 1 to 2. So it is 3. So this is how the Kruskal's algorithm works.